Hey, how's everyone doing? We got Dylan here, Abigail here, Maria here. We say we need some help. Great stuff. Not really a question associated with the homework, but maybe 2010. I'm just kind of lost on how to explain the ACF graph and what we learn and see from our data. Let's talk about that to review. Let me close down some stuff right here, reviewing the ACF. So we got first question of the day. We'll be reviewing the ACF. And that's BAS 475. And then I see we have a 320 question. So drop the questions in the chat if you got them. Is it the question 5? So here we go. Abigail asks, little chill music right here while we do this. Heading over here. And so Abigail says, here we'll put a time. BS 320, assignment 4. And this is question 5, B and C. Okay, question 5, B and C. Okay, let's head over here. And, I didn't get the timestamp perfect. Let's do this. Here we go. Okay, so we're talking about the ACF graphic. So, Dylan, what does ACF stand for? When we say ACF, ACF stands for a very specific thing. And what does ACF stand for? To be good. ACF stands for what? The what? ACF stands for the autocorrelation function. We did a bigger review of this last officer, so check that out too. And autocorrelation deals with our y variable autocorrelation function. Yeah. So we're going to look at the autocorrelation, which is how is a vector correlated with itself going back a certain amount of lags. So we don't have to do all these calculations. We should just understand that it is the vector itself. This is like the self vector right here, correlated back certain amounts of lag. So we're going back in time. So one of the best data sets to look at might be something with very strong seasonality to it. What do I mean by seasonality? Like weekly data, monthly data, quarterly data. So let's go ahead and take a data set from the AUS data set. Let's go here to the Australian livestock. So when you think about this Australian livestock data right here, probably this data is going to have very high autocorrelation where? On lag what? Just thinking about this, the way it's created, this data set probably has very high autocorrelation for something on what. So I'm going to start filtering stuff as we're talking about this. Let's go here to it's Tasmania or something. Levels, AUS, livestock, the state. What do you think? So let's filter. Oh, wait, gotta make it look all pretty. Filter on. Oh my gosh. Filter. Since the index is 1, not really 1. You're on the right track right there, Dylan. You're on the right track. Good. Look right here at this. That's the answer. Probably what we're going to see high autocorrelation. We might or might not. But probably your answer is correct, but not. Oh, you said 1 month. You updated. Yeah, 1 month. Exactly. Is Mewbot awake? Mewbot's not even awake right now. We got to wake up Mewbot. He just destroyed the world in the background. Hey, Cora, great to see you here. Drop a question in the chat if you got him. Mewbot's going to wake up right here. Let's talk about those lambs right there. We'll do another filter. Why not? State. Sure. No. Oh my gosh, Mewbot. You distract him, my man. Let's instead do it this way, which I think is another way to do it. Is to go here and say animal. I can spell animal. Like that. Adam Levine song. And say pigs. Okay, there's the Tasmanian pigs. What is the difference between Tisbil and Astisbil? I think they're the same. I think the Astisbil is more commonly used. So probably use the Astisbil. They probably are very similar. Cora, great question right there. If you find differences, tell me. Also, I understand the concept of number 7, but I'm just on what observations are you looking for? Oh, we'll put number 7 on here. We got one more question after this, I think, and we'll come back and do BAS 475, assignment 4, and question 7. We'll come back and talk about that here in a second. You got it, Cora. And so we're going to take this data here right now. And we should be able to do the ACF of it. There's the ACF. And then after we find the ACF, what can we do to the ACF? After we find the ACF, you probably think we're going to what the ACF here. So if we find the ACF, we can put the ACF through an auto plot, right? Always think about, ooh, hoo, hoo. So this right here shows that this data we're looking at has a very large what in it. And I can tell you right away because of this pattern. And then we'll talk about what is it telling us. This is something we mentioned in class. We should know this immediately. And there's a very, very, very strong what to that data. So I took off the ACF and I'm just looking at the plot itself. Very, very strong. Very, very strong what. Finally, for number 8, I have one series that runs with all the GD plots except for the GD season, which is confusing. Oh, maybe course, send me it. There's a very strong trend. The trend is the linear trend, and we're seeing that here by the very high autocorrelation at all points. That is when you have trend data, usually it just follows itself. Like the second point is correlated with the second previous point, or this point is correlated with 2 points backwards. It's also correlated with 3 points backwards. Very high autocorrelation right here. What we'd want to do, and is maybe, well, we're going to difference the counts, is it? Or it's the, or there's the ACFs. We want to go right here to the count. And so let me try this. Count right here. It's probably doing count by default. Cool, there's the count. And will it, I swear, it gets mad about this every day. Let me see where he uses diff in his book. Because I know there's a way to do this. I'm going to go here to the FPP3 and plot differences. So let me go to where he does diff. What? He sure differencing. ACF features. I know there's a quick way to do the differencing. Function. Well, that's interesting. Difference. That's okay. Wait, residual fitted. I did it in class just a little while ago, and I'm just like, well, I'm looking through the book right now just to see the function he uses if he does differencing right here, which we could do with an ARIMA model. That is a good way of difference. Hey, Colin, what's up? Good to see you here. Colin, happy magical pre-Friday, Haslam Friday right here. Good to see you here, Colin. I'm trying to think, because I swear, and I did it, like, all I can do it the way we did it. So, what I did after class to do some differencing of it is I'm going to take and mutate. I'm going to mutate this column right here. Well, let me first take the data set and store this as pig data. Okay, there's my pig data. And the pig data is a TISBL. Then I'm going to take my pig data and I'm going to pass it through a mutate. And my mutate is going to say diff equals, because we're going to store into the diff. We're setting it equal. You actually don't use the left arrow. You just says this is equal to this. You could probably left arrow it, but I use actually the equals for the mutate. Diff is equal to the function diff. So you got to be careful here. This is the function diff of the count. We might need to also append onto it a missingness at the start because it would be missing one value, and it did work. Okay, so that worked. It needs a missingness right here. But so to talk about differences here for a second, Dylan, does this make sense what a difference is? Like this value right here, if you look at the differencing right here, this value is a what right here. So this value right here is a what when you look at it. You can do this with an ARIMA model too. It's the D of the PDQ of an ARIMA. So that's probably why he doesn't do it, because it's something we'll be doing later on with code, but you could code it yourself. So I created a mutated column finding a vector. Hey, Kaler, good to see you here. To find the R squared, we just squared the correlation. Boom, 100 points. You got it. Great question / answer. Exactly. That's what that value is. Exactly. So that's what that value is. Then this value here is that difference right there. You could do a second order difference. You would just have to change the code. But once again, here, what we're going to look at mainly is if we take our pig data and we call this, like, let's just overwrite pig data right here. So there's the overwritten pig data, and now there's the pig data, and now we're going to pass it through a auto plot, and we're going to auto plot right here the diff just to confirm. And there's the differences right there. One row missing due to the NAs. Cover the BS Q5. Yeah, about to do some Q5 here in a bit. You got it, Spencer. Yep. And so now I'm going to take the ACF of this, and there's the ACF of it. And then I'm going to go to a plot of the auto plot, excuse me, an auto plot of the ACF. And what do you notice right here, Dylan? What do you notice right here? What do you notice right here? I see something, and there's a big thing, and this is what. No, Kayla, great job. That's a great question. It's exactly how we find R squared from correlation. What do you notice right here, Dylan? What is the most important thing you see? Like the big low-hanging fruit is that the differences, so many significant. This is definitely not white noise, right? This is not white noise. Like white noise would have about 5% random chance. We see way more than 5%. We see things way outside the blue lines. So to Dylan's question about how do we interpret this is if it is outside these blue bounds, it is what, Dylan? Like that one right there, the one I'm pointing to, that little tiny one.
Did someone say tiny?
Go away, tiny Brian. This little tiny one right here is not what? Correlation at lag 5. This is correlation at lag 5. Going back 5 periods and looking at a lag 5 correlation on the differences. So we're looking at the differences now. The correlation on lag 5 is what? The correlation on lag 5 is definitely what? This little tiny one. That one right there is what? It's not significant. It's very close to 0. Correlation close to 0, 320 review, is not statistically significant. Anything outside of this blue bands, once again, the sign doesn't matter. It doesn't matter. Is going to be statistically significant. The more extreme a correlation is, the closer it is to positive 1 or negative 1. The sign doesn't matter. The sign just tells you the direction of the correlation, 320-201 review. And so we're only concerned about, is it outside these blue bands? Now, the most significant correlation here is on lag what? The most statistically significant and greatest in magnitude correlation is on lag what? The strongest correlation in terms of magnitude is the correlation on what? The correlation on lag what? And this you could make a really good lag 12. Why do you think it's lag 12? Why do you think going back 12 periods in this data would show us and so we could probably control for this and look at it once we remove that variation. That's kind of our lowest hanging fruit right there. And why would it be on lag 12? Going back 12 periods in the data, why would there possibly be a very high correlation with the differences 12 months ago to what we see in differencing now? The reason is because, and I'm blocking it if I reappear, this is monthly data. So the most significant correlation with the differences are going to be with the monthly going back 12 months. It's 1 month index that there is seasonality. There's very strong seasonality to this data. This is monthly data, and sometimes monthly data might not have a seasonal pattern. Monthly data might be random. Like if I look at, I'm trying to think of something that wouldn't be correlated to months. If I look at I don't know. We're talking about number 10, right? Or just about number 10 a little bit. Like this is not a white noise process either. To like contrast, like that's not a white noise process. This is not a white noise process. That's not a white noise process. And that ACF is not a white noise process. We ended class today talking about what is a white noise process. And if you do have a white noise process, you're going to see something closer to this. That's not a white noise process. That requires some differencing. That is, I believe, the series we just looked at, differenced, where this is the original series, and then after differencing, it looks like more like a white noise process. White noise process is going to be more random and not have points that are outside, but you could have a random point or two that's outside. So do remember, if you start to go too extreme, you wouldn't say this is not a white noise process, because even though there is one significant, or like 1 or 2 or 3, we ran 100 tests right here. This goes to type 1 errors in Stat 201. So we don't really have significant autocorrelation right here. It's just because we ran so many tests. That's a bigger, higher level understanding. But we do want to understand correlation close to 0 is the weakest possible correlation. Correlation more extreme would go outside the blue bands. And look at this graphic right here. So close your eyes. Look at this graphic. Now close your eyes. and then look at this one all the way over here, which was the latest one we looked at, where we see more extreme. Look, the blue bands are a lot tighter because we had to zoom out on the graphic. Does that make sense right here, Dylan, to say, this is how I would interpret this? There is very strong evidence of high autocorrelation at lag 12. Also, there looks to be 4-period lag. Like maybe there's even some sort of quarterly thing. Actually, it's 3 periods, isn't it? 1, 2, 3. There's something quarterly going on here too. There's a very strong quarterly correlation because every 3 periods, which is a fourth of the year, you think about like 3 months is 1/4 of the year. Does that make sense? So I think we're seeing some quarterly seasonality and we're seeing very high yearly seasonality. So this data has in it, yeah. So that's what I get from this. Lag 1 and lag 5. There's some negative the big thing to catch right here is the positive autocorrelation. There's some negative autocorrelation too, but yeah. And then we can look at the PACF. We can just run an AutoArima. I know. Someone's like, don't run AutoArima. I'm like, but I want to. I just want to do it with the full search grid. Fun stuff. We'll be talking more about the ACF and PACF later on. We haven't even mentioned PACF, which is the partial autocorrelation function. But yeah, understanding what you're seeing right here to see that there's probably some sort of quarterly thing and probably some sort of yearly thing, turning this into information and knowledge where we see the significant spikes that are outside the bounds of what we would expect by random chance in the background. That's what we want to do. We want to make things make more sense. It is time for some 320 though. Oh, question 5 people were wondering about. That was a really good review of autocorrelation function. And the reason I love going into detail on those things is because that is also what we're covering in like 320 with correlation. So when you think about correlation in 320, we're talking about some correlation in 320 over here. Question 5. Oh, went to the wrong one. You're welcome, Dylan. Excellent questions. Everybody. Oh my gosh, I'm falling asleep. I need to wake up. Oh, good. This is the one I was working on earlier. Question 5. Re-timestamping it. Here we go. Question 5. Let's do it. It is time to talk some more correlation. Now with this, when you run the core demo, make sure to run it down here on the bottom of the screen. If you have any issues, please let us know immediately. I've had 3 people had issues this semester. Awesome, Dylan. Have fun today. 100 points right here for you. Core demo. Now, if you don't see core demo, you probably need to run what? Oh, was yours 475? We'll make sure to do it. You got it, Spencer. Which one was the... Did I write down your question, Spencer? Q5. I'm 475. Okay. Sorry about this, Spencer. BAS 475. Assignment 4. Question 5. Okay, I got it written down. Question 5. Oh, yeah, when you said question 5, a lot of people were asking about this one, so I thought it was 320. Thank you, Spencer. So, reg class. Abigail knows. So, reg class is what we need to have to run core demo, and then run it down here in the bottom. Now, we need to make a few of these graphics, and let's take a look. So, it says first, we need to... I'll do 2 of them. Why not? You're welcome, Spencer. Generate, well, that's the easy one. We'll leave the easy one. Let's go down here to the hard one. Question C. Generate a scatter plot which has a stream of points with an extreme outlier. Okay, cool. We'll worry about that later. Without the outlier, it should have a correlation close to 0, plus or minus. That's LaTeX writing right there to put it in. When you knit this, you'll see it looks all purdy. We can actually see what it looks like knitted. If you ever want to see what a knit document looks like knitted, you can click this button, and you can actually view what your knitted document would look like. So if you see all that kind of neato handwriting right there, when you go back up here, this is what it looks like when it's knitted. So we don't usually have to code that stuff. You could put it in Word afterwards, but there are ways to make R do purdy handwriting right there. But once again, do not worry about writing all this stuff. That the $ is called LaTeX handwriting or LaTeX coding, which we don't have to know how to code in LaTeX because we can just edit that in Word. But it says plus or minus. That's all we had to know. So we have to make a correlation close to 0. What would you like me to start drawing? If you'd like me to start drawing a correlation close to 0. So help me out right here. If I'm drawing a correlation close to 0, I could draw this. That has a correlation close to 0. Ooh, we did it. But preferably, I'm not going to draw one of the unique kind of weird ones that has a correlation close to 0. Preferably, I should probably draw a what to draw a correlation close to 0. Just think by virtue of correlation close to 0, it might make more sense to draw a what. Drawing a correlation close to 0, preferably, we might draw a what. What do you think would be more preferable than drawing a parabola, which parabolas do have correlations close to 0? The better I draw it, the better the correlation goes to 0. And so preferably, I would say, you should probably do a what instead. Instead of a parabola, if we're going to draw a correlation close to 0, what's a good idea to draw if we draw a correlation close to 0? This does have a correlation close to 0 because it does not have a linear relationship. Well, a U is going to be like an upside down parabola. You're on the right track. I wouldn't draw a U. So wait, here's a hint. Ready? If we want to draw a correlation close to 0, we should probably draw something that looks like a what? So if we want to draw a correlation that looks close to 0, we should probably draw something that looks like a what? Give me a big hint right there. If we want to draw a correlation that looks close to 0, what should we draw? Oh, 0, 100 points right there. Yeah, let's draw a 0. That's a good idea. I like that. Let's draw a 0. Okay, here we go. Boom, 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 boom. Draw my 0. Oh, look at that. Now you gotta be careful. This is a little bit too low net right now, so I'm gonna imagine a line going through. So I'm gonna go a little bit higher. That's a little bit too high. Need to go a little low, and boom, we got 0. 0's been obtained. Maria, great answer right there. Also, we got a 0. Now, with the red dot, the stream should have a correlation near 1. Where do you think I should put the dot? Over here? Down here? Well, I made it go negative. Where do you think I should put the red dot? I've got a 0, basically. And then the correlation, like if you draw around this, it would look like a 0 right now. But I want it to look more like 1, and I want it to be positive. So where do you think I should put that dot? Where should I put that dot? Any ideas, any guesses? Like, we want it to be positive. Top right, Maria, 100 points again. Great answers. That's going to cause an extreme like gravitational pull towards it. And boom, the correlation is very high now. So the correlation right here is 0.91. Another way I like to do this one is if you actually make a box. I didn't do it via this methodology. If you make a perfect box, you get a correlation of 0. You have to make a perfect one, though. Hey, perfect box. And then if you draw your box tight enough, you can actually get a correlation super close to 1. So if I do this methodology of solving this problem right here, and I make an even tighter one, nope. I will not. I must have the perfect answer. I'm failing. I knew what anyone else getting the point. Never have me play it. Oh, there we go. There we go. That's the best we can do. Is this making sense for this one right here? That is just a blob of points, and then that one point causes a relationship. So what do we say? QQ straight enough. 201 knows. QQ straight enough. We don't like those things. What do we say? QQ straight enough. I'll bring up the next question right here. You think about, we don't want that thing right there. QQ straight enough. What's the end of the saying? We don't like those things. We don't like them. Because those things right there can do anything. Those things are bad. Those things right there. Where did we mark it? We marked it in the notes yesterday. No outliers. Cora knows some QQ straight enough. No outliers. We took notes yesterday in 201 as we went through and said, what can outliers do? They can do anything to a correlation. So outliers can do anything. Can we do B? I will do it. Hey, Nolan, great to see you here. We don't want those outliers. These are test questions right here. Can outliers do this to correlation? Yes. Anything. Anything. So let's think about B right here. And how can we possibly solve B? Okay, generate a scatter plot which has a stream of points with an extreme outlier. The stream should have a correlation of this. Okay, so if it has a correlation of 0.7, that means the correlation must be what? Correlation of 0.7 means it must be what? 0.7, not negative 0.7. So correlation of 0.7 means it must be what? Correlation of 0.7 means the correlation is what? What words would you use to describe a correlation of 0.7? If someone says, oh, it has a 0.7 correlation, you say, oh, it's this, and it's probably a little bit this. So correlation of 0.7 is something we would say has a what correlation? Well, virtue of 0.7, not negative 0.7, it has to be this. What is it going to be? How will we describe it? Because then we can figure out how to draw it. 0.7 is definitely a this correlation. The next word we use will be a little bit subjective. Hint, I would say it's moderately strong. Why moderately strong? It's higher than 0.5, less than 1. 1 is perfect, where 0.5 is moderate. 0.8 is maybe strong. So I'm going to say it's moderately strong, but I do also know it's what? I do also know it's what by being 0.7, not negative 0.7. By saying it's 0.7, it must be this direction. 0.7 means it needs to be what? You might think it's just obvious. You're like, well, of course it's this. It's 0.7, not negative 0.7. 0.7 indicates that the relationship is what? Sutat says. 0.7 means that it is positive. It goes up. So when we think about this, would that be 0.7? That's to what? That's to what? Positive. Great job, Nolan, right there. Excellent work. Nolan, this correlation looks to what right now? It's 1. It's not 0.7. Not quite steep. Nolan, good answers right there. Not quite steep. The steepness of the line has nothing to do with the correlation. Good answers right there. Oh, nice job. Yeah, well, we can go back and we can look at sensor. Thank you so much. Spencer checking out those earlier office hours. The steepness of the line does not indicate the strength of the relationship. The steepness of the line does not indicate the strength of the relationship. The what of the points. And so good review right here. The what of the points indicates the strength. So 201, 320 should all know this. The what of the points around the form of the relationship. The what of the points. So the steepness of the line does not indicate the strength of the relationship. The what? So the steepness, Rock knows.
It doesn't matter.
100 points right there, Spencer. The steepness doesn't matter. What matters is how what the points are around like the line. How what they are. Because this is too strong right here. So the steepness of the line will not change the strength, but the how tight they are. Nolan, great job. Another 100 points. Good recovery right there. You got this. How tight they are. So what we'd say is we need to exactly spread them out more, right? So take a look as I spread them out more. Oh, that was 0.7. I should have stopped. I can spread them out a little more again, put more towards the center, and there you go, 0.7. So generate a scatter plot which has a stream of points with an extreme outlier without the red dot. The stream should have a correlation of 0.7 plus or minus 0.05. Well, right now it has 0.7. That's the correlation right there. And with the outlier, it should have something close to 0. So right now, linearly, this goes like this. Can you tell what I would need to put through this to bring the line back down? What I'm visually speaking about is what we have is a line going through our data that looks like that. So where should I put something to create a gravitational pull to like bring the line and make the line flat? So I need some sort of like far away thing that's going to be an outlier that's going to kind of destroy the relationship and cause it to have a correlation closer to 0. Cause, I mean, yes, mathematical. So I can maybe say that. Or create the mathematical scenario in which we get a correlation that is like what's now destroyed. It doesn't exist anymore, or not, is basically 0. Does not exist, is incalculable, which is only in certain scenarios. Where would we put it? We want to say, okay, it currently has a pretty strong positive bottom right. Great answers, Maria, right there. You bet. We'd go down here and we'd say, how about right there? No, what's really great about this app right here is we can go in and we can give a guess and say, what about right there? Oh, so close. I'm blocking it. So close. There we go. Second try. Those points are for me right there. We have literally followed the directions to the T, creating an exact graphic that shows. Now make sure when doing this to take screenshots of your graphic. I highly support the taking of screenshots, and then put this in your knitted document afterwards. So after you create this and go through here, make sure to go to your knitted assignment and then copy paste that in. I've got a knitted assignment here somewhere. Well, let's pretend this is your knitted assignment. go down here to where you would put the picture in and then drop it in. Probably one of the best ways to put a picture in, and as long as the picture's in there, you're good. So Maria, is this making more sense right here? We created some cool graphics earlier. We made this graphic. That was a lot of fun right there. It looks like heart. We should have done that for Valentine's Day. Yep, I believe so. It says within a region of plus or minus, so you should be good. You've got a plus or minus 0.2, so you are within that bounds. Maria, excellent work. I think we only have one more question, so if you're here, just kidding, got 0. Maria, 100 points. Maria, trying to get those. You're welcome, Abigail, and that's what we're here to do. It's, like, I know I realize I'm doing the work, but it's we need to understand the concepts and talk through them. Like, it's all about understanding it. It's all about learning the concepts. So if we learn the concepts, that's all that matters. And that's what we do. We're just here to learn. You're welcome, Maria. Excellent work. Let's head back to the main screen. Okay. It is time. A little music. We've got another question. The next question is question 7. We haven't done question 7 yet, I don't think. 31. Ooh. Okay, let's go check out. Oh, gotta bring up the assignment. BAS 475. I think it says key on this, but it's not the key. Okay, let's go look at some questions. 7. Look at the timestamp. Here we go. Okay, we're doing BAS 475, question 7. And with question 7, we're going to look at some seasonality and stuff. Question 7 says, the Australian arrivals dataset compares quarterly, so it's on a 4 lag, international arrivals to Australia from Japan, New Zealand, UK, and US. Use the autoplot GG season, GG sub-series to compare the differences between the arrivals for these 4 countries. Can you identify unusual observations? Give full credit. A student makes, yeah. Yep. I had those notes? Sure. Okay. So when it comes to this right here, I like to make some really good graphics. So what do I mean by that? We've got a lot of options right here. Let's bring up the FPP3. And let's go here, pull it up, and go to the AUS arrivals. There we go. Here's the Australian arrivals from Japan, all these countries. Australia and Japan are so close together. One of my friends is in Australia, and he gets to go to Japan all the time, and I'm super jealous. One of these days, maybe I'll get to go to Japan. That'd be cool. And what we want to do right now is think about this. How about we create all of our own data sets? I wonder if there's a, I don't think there's a quick way to do it. There might be. If you're in the chat and you're in 475, I'd love to know a quick way to do this. Or 320, anyone could figure this out. Go to select and go to origin equals and Japan. And and arrivals from New Zealand. UK, US. There we go. Ooh, problem. Is origin wrong? Error. It is NZ. And then I have another problem, Cora 100 points. It is NZ. And I made a mistake. So there's one other error. Because I'll point to it. I did it, and I do it every so often because it's because of I don't know. I think it's because we generally use in 320 to do subsetting. There's something issue right here. Think of an F. There's a error right here, Cora. Yep, filter. Yep, that's what we did. It's mad. And now let's go look. Boop, boop, boop. Okay, cool. Let's go here. Do a little. What I'm gonna do is I could do this a bunch of steps. I'm gonna say JP, NZ, UK, and US. So now we have 4 Tisbles, which you could just follow through. Does this make sense what I'm doing here, Cora? Is now I just have my 4 Tisbles, so I just have those data sets by themselves. Like I just want to be like, these are my data sets. This is what I'm working with. These are the things I'm going to look at right here, which might make things a little bit easier. Like just in terms of like, I'm just breaking it apart. I'm just saying, okay, this was all in one big data sheet. Now I'm going to create my own 4 data sets right here, which is their own things. And we'll take a look at each of these individually. Cool. So now what we do is we go right here and we say, let's look at Japan. And we want to take Japan and look at the auto plot of Japan. And it automatically chose that for us. Now I wonder if auto plots color feature. Oh, it did it. It did it. Cool. And now we should be able to take and go here to NZ, UK, US, red, green. Cool. Oof, oof, oof. Purple. There's that. Let's go here and say plus GG title. And we'll say Japan arrivals. This is how we build. We double check. It is working. And I'm going to do one last thing on here. Plus easy center title. Okay. So Cora, this is what I think is very important right here. And we're going to show some communication ideas right here, which like goes into Stat Tool 1. So Cora, what are you thinking as we go through here and we kind of create this? And you notice a lot of this code is basically what? What do you, whoops, got to be careful as you do it. What do you notice a lot of my coding is right now? When it comes to coding, a lot of it mostly is what? Like a lot of coding, a lot of times, there's a lot of copy paste. So watch this. P1 for picture 1. P2. And we could make it, I'm going to do it as one line right there. I could break it apart. Okay, good. And then P4. Cool. Okay, now I'm going to do something. So I need to have library ggpubr. And please slow me down. It's making sense. That's what I like to see. If I'm saying something too fast or I'm going too quickly, let me know. I'm just adding titles to these. I'm centering the title. I'm doing all these things. And we go here to ggArrange. ggArrange arranges your plots for you. I might have to look at the syntax again for it because I don't use it every so often. But we go here to P1, P2, P3, P4. And let me double check ggArrange because I used it. Ooh, I don't have it up, the one I used. Well, that's perfectly fine for me right there. There you go. There's all 4 plots in one plot. Oh, it does. That's right, Shreya. But there's all 4 plots in one image created for us right here. And I want to show you why I did it this way. And we could probably add a title to this. I wonder if I go to the ggArrange and go to plus, let's try this, plus GG title, and say all arrivals by country, and then go to plus easy center title. There we go. There it is. There's your graphic. There is a great graphic. Oh no, it's Shreya asked those questions. 100 points. Thank you for asking and saying. But what is the point? We try to say this a lot about this class. What is the point of, and we could maybe put them on the same scale. I might need to like do a Y limits thing or something. Like I think I could control the Y limits of the auto plots. But 474 kind of seems kind of tough. It can be challenging. 320 student here, I can follow and understand a little. Nice job, Nolan. It is 475. Yeah, it is 475. So the fact that you're following a little bit is great. So you're seeing a lot of new code, and the fact that you're in 320 and you're following a little bit is awesome. Because we just did a lot of cool stuff. And does this look like a nice graphic for a presentation? And then I want to show you something that's really great. Because if I want to look at the seasonality, I want to show you what we can do. So now we're going to do a totally different thing with all this code we just wrote. We just spent a bunch of time writing a bunch of code, right? But let's take all of this stuff right here, and Cora is going to help us out, I bet. I bet Cora will know the answer. Cora, I'm putting you on the spot right there. Looking at this code right here that we have. So, can you show the code again? Yep, I've got the code all on the screen here. Let me hide user on channel. You're gone. With all this code here on the screen, I no longer want to do the auto plots. With all this code on the screen, I don't want to do the auto plots. Never mind, I got a great job. I don't want to do the auto plots. I'd rather look at seasonality. So Cora, I want to change something right here, and I want to change everything I've done to look at seasonality now. So now I want to be like, let me instead look at seasonality. So now I instead want to be like, let me look at seasonality now. What should I do? Because with all this work I've done, and truthfully, Rock knows this top part right here doesn't matter.
It doesn't matter!
With all that work I've done, I can look at seasonality very quickly. I should be able to. What could I do? I'm hoping it... We might need to remove something. Not a for loop, not a for loop. Because, well, I guess we could. I guess we could have done that, right? There might be a way to for loop it. It's always a question, right? Can we for loop it? We don't need to for loop it. We could shiny app it. Or we could change one argument in here from something to something else and get all the seasonality plots. So we could change one argument in here with all this code we spent the time writing, because we got all this nice pretty code right here that makes this nice cool graphic. But instead we could look at the seasonality of all of these. How? We could look at all the seasonalities. How? Like instead of like we got all the auto plots, how could we then say, let's look at something a little bit different? And we're probably going to have to remove the, I might say argument, I might say function. We're going to change a function, and we're going to remove the argument inside the function. You just, perfect, Cora, 100 points, you were exactly right. And so here's the GG season. And we're going to remove this. And theoretically, this should work. I'm going to do the polar equals true. Oh, watch this. Polar equals 1. Why does 1 work if I say polar equals 1 instead of true? There you go. And there's the seasonality of it. Pretty interesting. New Zealand has some seasonality in July, lower in January. Yeah, I know, right? You're like, oh, wait, that's just it? We don't need to for loop it? Ooh, UK is pretty weird. Japan has a dip in April. Yep, exactly. True and 1 are the same thing. So you can just write 1 or you can write T. So all of this right here, we could go to the GG sub season. GG sub. How much am I changing and how much am I getting out of this? Whoa, don't do that. Does this make sense, Cora, that I am doing minimum effort right now? And then for this minimum effort, I get all new plots. Changing little, getting a lot. And that's why we're like compartmentalizing this code right here. This definitely makes it clear when it comes to New Zealand, there's a what. There's some seasonality when it comes to New Zealand, but New Zealand definitely has what going on right here. Like this right here from year to year, Q3 consistently. There is seasonality to New Zealand, Q3 highs, some seasonality to Japan, Q2 lows, seasonality to UK, Q2 and 3 lows, Q1 and 4 high, seasonality. US is one of the least seasonals, but most of this. US has a very strong this, where New Zealand has a very strong this. Japan might be in some sort of cyclical process, as might UK. There is some seasonality, or that other word that I'm trying not to say. Very apparent in New Zealand, very apparent in US. Japan might have had a change in process or something, or be going through a cyclical process. Japan would be one of the hardest ones to predict. New Zealand is probably one of the easiest one to predict where it's going. So what am I seeing right here, Cora? With New Zealand and US, I'm really seeing a lot of what? what am I trying to point to right here by saying this trend? There's a strong trend. Which is just a linear process. There's a very strong trend. There is some aberrations, especially this right here in the US. So we see some weirdness, but that's a really weird jump right there. Trying to think what other weirdness we see. Q4 is definitely higher in the UK arrivals, but that's a pretty weird thing with the US. Some of the other plots might show the weirdness better. Frankly, our original plot right here, we just did all different 4 types of plots. That point right there in the UK arrivals, when is that? That's one of the peak ones around the 2007. A peak UK arrival around 2007. Oh, whoa. Oh, here we go. UK arrivals, and it looks like it's that. So it's in the peak quarter. So it's this right here. Yeah, it's a little bit high, and we're seeing a change in process. But you have to go through and just describe this in your own words. I don't want to say everything I can about this, but it's just talking about it. I mean, like, that's a little weird over there on the US Q1 around the late 80s. Sudden spike and dip. Weirdness right there, things that don't really follow the pattern. But just think about how you talk about it. Oh, Japan's got a really weird dip right there. I mean, just think about this. If this is a mountain, there's a sudden landslide or cave-in right there, and it also appears in Q2 for that year. So that's kind of weird, the sudden drop in a leveling off pattern. I'd want to know what went on there. That's weird. So does that make sense, Cora, what to look at here? It's basically just like, you know, if you could think about what looks odd, like these swings are a little bit smoother, like what doesn't follow the trends, what doesn't follow the patterns here. And all the graphics tell different stories, or they tell the same story but differently. Because this is going to be really great for looking at seasonality, but because we can see the push in on these quarters and the pull out. So UK's got like this outward pull on January and October, and then in April and July it's got like a push inward. So thinking about where is it going out or where is it going in is going to tell you where it's kind of hitting its local maxes and mins. So April and July, going to the next graphic, or over here on the UK where you see the lower areas, these are the April-July quarter, and then over here in the Q1, Q4 are where you get back here to the end of the year, rather Q1, Q4, but Q4, Q1 if you go in the order of like a circle going around the year. Or rather, I don't know, if you go here, then you got to go Q1, Q4. So yeah, a lot of great stuff. And once again, we try to make our code look pretty. I guess I could have gone here and done the following. It just gets really long, and I decided to write it as one line. I was virgin onto that whole. I really need to make it look awesome, Cora. That's what we want to see, and then you can look at that right there and break it apart, and you could just pipe in. But that's got it, and we're storing that into a graphic. So we'll head back here to the main screen. I think we don't have any questions right now. So I was going a little long on that one. A lot of really cool GG plots on that. It's Hasm Friday. Maybe we'll do a little bit earlier or something. Not right now, though. If you have questions, let us know. It is just open questions. I'll see what's going on. Random fact, I went to Best Buy and bought a new monitor. Oh, Nolan, that's awesome. That's cool, Nolan. Oh, yeah, got a question number 8? Yeah, let's do number 8. He'll be very happy with that. So let me, question 8. That's awesome. What kind of monitor do you get? But I already sent you my code, so it's not a pressing matter. Do you want me to just like let's see if this helps here, Cora. Nolan, what kind of monitor you get? Could you do more deturning? I'm having trouble with 8 and 9. Oh, there we go. I look away for a second. I was like, watching. I was thinking what was going on with the world today. The world is a crazy place. The world is a crazy place. In the words of Smashing Pumpkins, the world is a vampire sent to drain, seek a destroyer, hold you up to the flame. Yeah, that's awesome. Wow, we're inspiring people to get monitors. What are you? I can't sing. I don't know the lyrics either. That's cool. No, just need a basic. Like, there's diminishing return when you buy technology. If you go all out, there's diminishing return. I'm really lucky. I've got a pretty nice, what is it? It's a Dell monitor. Dude, you're getting a Dell. I'm a 2000s kid. But there's diminishing return. Like, you go from a $200 monitor to like a $2,000 monitor. Yeah, a $2,000 monitor is going to look better, but $1,800 better. Imagine if you filled your room with, what would you rather have? I will either buy you right now, not literally, 10 $200 monitors, and we can hook them up to have like a multi-crazy display, or I will buy for you one monitor of the same size that is $2,000. What are you picking? We'll ask in the chat. Which one? We'll do the question. Would you rather have 10 monitors that cost $200, all hooked up? Depends on your areas, right? Hooked up. 10 monitors that cost $200, or one monitor. Either way, we're spending $2,000. That costs. Now, if you say one monitor, then it's $2,000. One monitor. Okay, which one would you rather have? Very interested to see. We'll see what people say. It'd be really cool if you created like some sort of grid. You could do it. You could say 9. Say, okay, now just maybe do the one of the 10 over on its side, so it's just a monitor, and you do a grid of like the other ones where you could do like a multi-display. You know, like when you go to like a bar or something, and they've got like all the things on different screens. You walk in, you're like, oh, we got stocks trading over here, all that stuff. The 10 monitors is winning. Hey, if we're gonna spend $2,000, kind of weird, right? I mean, we never think of things that way. But it's almost like we know a $200 is worth, this $200 monitor has this much worth to us. And it's like, wait a minute, I could have backups of it or something. I don't know. It does have storage space for it or ability to display on all of them. That would maybe change our minds. Okay, question number 8. Series 1. Okay, using the following graphic functions: autoplot, GG season plot, GG lag, and ACF. I don't use GG lag so often. Explore features from 2 of the following time series: total private employed from U.S. employment, bricks from OS production, hair pelt from pelt, HO2 from costs from the this is the Australian pharmaceutical something, and US gasoline. Okay, I'm gonna try not to do too much on this. I don't want to do the full problem, but you know, we'll do parts of it right here. Can you spot seasonality, cycle, we'll just say cycle, or trend? These are the 3 major components by which we have in time series. So just going through the notes. So time series patterns right here. Can't believe I actually landed around that. 100 points for Brian. Time series patterns we have right here. Please go back and check the lectures where we go more in depth and we draw on the slides. So the patterns we have in this series are trend. A lot of times we're just talking about a long-term increase or decrease. Most times linear. So it's almost like we're talking about correlation with the form of the correlation. The seasonality is a kind of consistent pattern, whether it be quarterly, weekly, monthly, daily, all that good stuff. Where cycles, my drawing's all right for cycles, but here's where you see the not fixed pattern, where the fixed pattern is the monthly season, and the trend is some sort of linear leveling off trend, but there's a cycle kind of pulling up and down on it. So there's some sort of not fixed pattern right here, and maybe a little shift to the series at some point. What's going on? I don't know. Has it leveled off? I don't know. Different models are going to predict different things because frankly, someone might say, maybe we're just in like a steady state with seasonality. At that point, a seasonal naive model might be the right answer. What's the right answer? Who knows? Statisticians will make suggestions and we will analyze and make guesses and have metrics to view those guesses. That's what we're going to do. First off, we just need to know how to talk about it. And that's what we're learning about right now is just how to talk about this stuff. So let's bring up one of these series. What should we pick? Everyone's getting those 10 monitors. Should we go for the employment, the bricks, the hairs, the HO2, the US gasoline? What should we look at? Any thoughts? You direct me. Be like, I'd really like to know more about US gasoline. That is my area of interest. I wish we had video game sales. I wonder if you could go scrape some video game sales. Ooh, let me go find real quick. If we're a little thinking music right here. Monthly, I'm gonna try to find one. Monthly video game sales in the US, CSV. Data from video game reviews. Video game reviews. We don't want video game reviews. We want video game sales. Kaggle. Whoa. It's video game reviews. We don't want video game reviews, though. It's not a time series. Video game CSV. No, we would need the sales. Video game sales data Reddit. Ooh, they got it on Kaggle. Kaggle is a website where, hey, what's up, Brandon? Great to see you here. Hairs, want to do some hairs? We're going to maybe get some video game stuff. So the data right here, download 18 megabytes. All right, we're going to open some stuff on Pure. I don't know if you teach 471. You can ask me. Probably the best thing to do is to drop it in the 471 Discord. We got 471 instructors in the Discord to help out. And that's going to be a big thing right there. They are super awesome. I think are both Adams teaching 471? Is Nana Bryant, Dr. Nana Bryant teaching 471? I hate it when people give weird names to stuff. We're going to make our own Tizbowl here. You can always ask a question. I might say, I don't know. I've never taught 471, so sometimes my answers are, I don't know. Where did I just unzip that to? You know what we do? We just drag drop. Drag drop better than unzip. You'll see here in a second. There we go. Let's go V sales. Let's go back over here. Boop. Okay, we found it thanks to Kaggle. V sales. I think read.csv. Let's see if it looks anything similar to what we can do. V sales. Okay, cool. I did spell that correctly. You will not have this. Hence, I like using data sets you don't have so we can do like all new problems. So we've got some video game sales. What does this data set look like? Please be usable. Let's just delete all that we have. Let's take out our images and then let's reload it. Wow, that's a big data set. It's sales of all the video games. There might be a way to do this. It's got the year. It's got the year, and I might be able to do this. I might be able to do this. It's going to require an aggregate. And I should know how to do this pretty quickly. Are not sales for that? There should be like a total sales. Total shipped. It's probably like millions. Wait, why is there not global sales for that? Grand Theft Auto 5. Grand Theft Auto Vice City. These are the top selling video games of all time. Grand Theft Auto Vice City, Red Dead. So Rockstar, which did Red Dead 2, Grand Theft Auto, Call of Duty, Black Ops 2, Black Ops 1, Black Ops 3, literally all the Black Ops up there. FIFA, sports games, FIFA 18, FIFA 17. Just Dance, I did not know Just Dance was that high on the list. Halo 4, obviously, Grand Theft Auto, everywhere, Fallout 4. So this is real data right here, pretty interesting stuff. Crash Bandicoot 2, I didn't know it was that high. Battlefront, yeah, that was pretty popular. Battlefield, well, those are all right next to each other. And this is the sales. We have it organized by global sales. Okay, cool. So what we want to do now is we want to work with this data, and we want to take and aggregate it, where we want to look at the global sales by year. We want to do a sum of it. So we're going to aggregate this data. We're going to have something to work with here in a second. And we want to say, go to, I want to look at the global sales. This will be kind of cool. I'm very excited to see this. Global sales by year. And this is the fun of working with real data. You get to work with a data set that you don't even know how it's organized at first. Oh, fun. I didn't give it a function. It says, what function do you want to use? And I say, okay, we'll do a function to it. Of course, because that's what I'm doing this for. There we go. Ooh, whoa. This is weird. Something's wrong. Something's weird in the neighborhood. Something's weird in the neighborhood. What's weird in this neighborhood right here? This series, and that's weird too. I wonder if how accurate this is. What do you notice about this? I don't know if this data has been collected properly and has everything because there's major issues with this. Because I would have a hard time believing with what I know that this is accurate at this point. Maybe up to a point. Yeah, and where do you notice that this series just doesn't seem right if you know anything about video games? Like, or just if you didn't hear, like, because look at the numbers, look at this, and then look at back here in 85, which is when you're talking the era of Atari. Interesting. It's just we're talking about the top games, and I just wonder how accurate this is. Yeah, this is 2019 and 2020. There's like no one was buying games apparently. It's just people just said, "Nah, not going to buy games." Which I have a hard time believing that. I just think their data set doesn't have data reliable for those years. So I think because if you look at the global sales, they're saying these games have like next to no global sales. What games are these? Plague Inc. I don't know that. Final Fantasy, Raft, Dragon Quest. Dragon Quest is slightly popular. I've heard of that one. I've heard of most of these. Wasteland, of course. Destroy All Humans, a game that re-came out. Good game right there. World of Tanks. Everyone likes that. Let It Die. I don't know that one. Jewel Quest 6. I didn't even know Jewel Quest kept going. People said COVID. I don't want to play video games. COVID, I'm done with those video games. Music. Wonder if that's a typo in their data frame. Crazy Taxi 3. A Boy and His Blob. Oh, that's Nintendo. Boy and His Blob. That's a classic game that re-came out in 2020. I didn't know that re-came out then. I guess I heard about it then. I just think something's wrong with this data at a certain point. Okay, so I'm going to say this data set is unreliable after 2017. Okay. So my idea is that this data set is reliable up till 2017, which means I'm doing this right here. Oh, it doesn't like rows columns. Rows columns. Come on, Brian. Okay, does that make sense, Cora? We're going to call this video games. And here's our video games. And so now we have a video game data set. And with the video game data set, we need to turn it into a what, Cora? This is a great review of the topics we've been covering. We need to turn this into a what now? So I just removed out the last 3 of it. Could have done it maybe another way, but I could have like filtered and said year less than blah, 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 blah. But I'm just like, let me just hard code some numbers. Probably should have done a filter. I know. Want to turn it into a Tizble. Okay. I'm going to use this methodology as.tizble. And we need to have that it is indexed on year. Surely nothing is as easy as it sounds, right? And we go right here and put the video games in here. And we're good to go. Video games, we're going to overwrite it because you love overwriting stuff, especially if you make errors and overwrite it. That's horrible. And then we're going to go to video games. The variable is global sales. I'm going to overwrite. So I'm going to overwrite the name of it. So I'm going to go to call names of video games and overwrite column name 2 as sales. We're just going to call it sales. So call names, if you don't mind. There we go. And so now we're going to go. So now it's called sales by virtue of in the video games data set, it's going to be called sales. And now here we go. Let's take a look. Now, the problem is we're not going to have strong seasonality, Cora. Why? Why would we not have strong seasonality with this data set? Maybe there is some sort of trend in this data set because it's Whatley data. So we're probably not going to see strong seasonality with this data set because the seasonality is going to be a consistent pattern over a fixed time frame. There might be some sort of cyclical pattern, but I don't expect to see seasonality because we're really not set up with data like that. I wish we could have like monthly data on this, but I highly doubt we're going to see a very strong. I mean, we really just don't even have the right thing. We're going to see a trend, I bet. Which there's going to be a change because people don't buy. Kind of. Well, they might, especially Black Friday and stuff. There is probably seasonality to this, but our data doesn't have that feature to it. Does that make sense? There is seasonality, I would say, to video game buying to some extent, like Christmas and November. But the problem is our data is collected yearly. So with the yearly data, we're probably not going to be able to really we just don't have the capability of parsing out that seasonality. So we're mainly going to be looking at trend right here. So everything we're doing is going to be like trend related. So let's go to autoplot in disguise. Let's first call it data. That'd be a good idea. And then let's autoplot the sales. And there it is. Yeah, look at that. I mean, this might be accurate. I'm wondering how accurate this is. And one of the things I do love to do is if we can autoplot it, we can always ggplotly it, or we should be able to. A little bit nicer stuff. We could add a title to this and say plus GG title. And we'll kind of do the steps right here. GG title of video game yearly sales, yearly video game sales. And then we'll do a little sub there. There we go, that. And then we'll add another thing. We'll go easy center title. This just centers the title for us. And then what you have to know is you have to put this all in an evaluation right there and then run it. So now we get a little bit nicer of a graphic. Gonna do its thing. It's not happy today. Why is it sad? Well, I'll be. Okay, let's run it in parts and see what it got mad about. Okay, we'll remove out the ggplot at the end. We'll just see if the ggplot was the issue. There we go. Oh, we got an extra parentheses. Okay, that worked. Okay, let's store this into the graphic P right here, just for placeholder right there. And ggplotly. Oh, sure, that worked. But pretty easy to communicate what's going on right here. And this is what I really love, Core, about this, is if you make a graphic like this, you can only put this in HTML, and it's really mad at me today. It's just saying no all the time. It's like, you cannot have your graphics. And I'm just like, okay, I'm sorry. But with this right here, we have a pretty good communication ability for what the sales were. How accurate are these numbers? I hope they're accurate. Not like hope like I want them to be accurate, but I want the numbers to be correct when I show them. I am concerned about how there's this sudden drop off, which maybe I didn't know about. Not like it concerns me. But if video game sales peaked, you know what that was? When was GTA 5 released? When did GTA 5 come out? No, 2013. Almost 10 years ago. 2013. So the GTA 5 sales, which are a huge thing, are part of this year. What games came out in 2008? Got a jet. Awesome job, Spencer. If you have questions, let me know. Whatever came out in 2008, I don't know why it's so high. Let's look at top games of 2008. So, top video game sales, 2008. Mario Kart, maybe it's because Mario Kart's still out. I don't know. Mario Kart's still out today. Wait, Grand Theft Auto 4 came out then. Smash Bros. And Call of Duty. Increasing trend. Yeah, it looks like there's a change to the series. I'm wondering why. It might also be sales for those games that the year they came out. That's the problem we're running into too. Which, you know what this indicates to me, Cora? Is I think it's the sales of the games and the year the game came out. So the peak year for games. So this is the thing. It's Xbox 360. Yeah, it's around that time, William. You are right. 100 points. Xbox 360 is 08 or so. I remember where I was at when I got an Xbox 360. I got an Xbox 360 in 09, I think. Gosh. Something to talk about that stuff, right? Like, oh yeah, 2009, I got an Xbox 360. But this is the sales of the games that came out that year. So think about this. These games, which I think this might be accurate now, why might there be lower sales for these games that came out here? I'm the 2018, 2019, 2020 data, I'm a little bit concerned about that. But why might there be lower sales for games that came out in 2017? Because remember, this is like the total sales for games in 2008. Why might there be lower sales over here? Because these games have been out longer. They're not as they haven't been out as long, right? So this is like the global sales over the long time. And so I think that helps explain our series, is that the data is collected like not the sales it did that year, but Mario Kart 8, which is crazy popular. Was Mario Kart 8 came out in 2008? No, wait. Mario Kart 8 came out for the Wii U. The Wii U came out in... Wait, okay. No, the Wii U came out in like 2012 or so. Mario Kart 8 came out in like 2014. That's, I think, Mario Kart 7 I saw. Yeah, you got a Wii. 2000, the Wii came out in like 06, no, over 7 or so. The Wii came out right after the PlayStation 5, like a week or two after. I remember PlayStation, what am I saying? PlayStation 3. I'm forgetting my video game history. Wii came out right after PlayStation 3, and that'd be the time of Xbox 360. Man, I was actually looking at a PS3 game last night. I was looking at Batman Arkham Origins, which is a good game that I never beat because my disc was broken. I love all the Batman games. Got some Rick and Morty today. So when we look at this, we can't get the seasonality plot, I don't think. Here, I'll go into another one. Let's go look at the U.S. gasoline. Here we go. We'll do something already created for us. All right, there's the gasoline. This is weekly data. Yeah, that's got some trend and got some weekly seasonality to it. So if we take this right here, this data is already cleaned for us, so we're fine on it. Like, I bet the sub season, is it going to do every week? Please do it. I'd love that. I bet it is. I bet it's thinking. Oh, that's beautiful. It's absolutely beautiful. Let's zoom out and take a look at this. I love it. You'd say you're crazy, and I say, you bet. Okay, let's take a relook. Is it going to work? We might get something tangible here in a moment. I get something from this. I don't know if we have all the plots, though. We do. We do. This is the barrels. This communicates me. It's horrible. Brian is beautiful. 100 points. What story are you getting from this? What story do you get from this? And there's a story to be had about summertime drifting away. Oh, 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 those summer times. And you can see the other story to be told. There's a story to be told right here with these blue bars. There is a story to be told with these blue bars. What is the story with the blue bars? Which, frankly, the easiest plot to see this in might be... It's going to be easier to see. Wait, what? Now it'll do it. Ooh. I think it's easier to see in the previous plot. No. Careful. Not the trend. So you're right, Cora. You're right with what you said, but not the trend. So you've blended terms, but 100 points, Cora. Not the trend. I mean, I understand what you're... Yes, exactly. The seasonality shows in summertime. Yeah, the seasonality, there's a higher... It's actually a little bit harder to see right here, but you can tell there's that little bit of a lift during that time period. Funny enough, this ridiculous graphic is showing it a little bit better by looking at the means of these series for each year. It's a bit ridiculous, but hey, that's what we're here to do. These are each of the weeks. So you're seeing the highest around 26, which is out of the 52 weeks, the middle point. Bit ridiculous. I would not put this in a report. Funny enough, I just think it actually communicates the information a little bit better than this. I wish there was like a mean going through this. I don't think it has that option to do it in the, like, would the word be like seasonal? The seasonal high, yeah. I'd say that, you know, this is 52 week, or this is weekly data. We see that the highest point is during the summer months, the weeks, or we should say the summer weeks, comprising around week 19. That's week 19 if you can't read it right there. I know it's very tiny. But around week 19, so light up here. I would not include this report in a report. Around week 19 through week 35, we generally see the peak going back down through the remainder of the end of the year, week 36, till it goes through the year and starts to rise back up again when I said around week 19. I mean, it's not like it's a very kind of a flow through it. And you do see that in the other graphic, that there's this sort of flow. You're actually looking at, and I'll draw it on here. Always helps to kind of draw what we're thinking about. Because I don't think we can get it to plot this for us, but I wish we could. I mean, there's always a way. Yeah, I mean, I'd have to do like an 80 line or something. I don't know. I'd have to spend another 5 minutes doing it. We're talking about that. Does that make, like, you want to take the mean of all these weeks? So what I would need to do, could I do it easily? I need to find the mean of every week. So I'd need to do an aggregate by week and find the mean of every week, and then do like a plus AB line with the values. You know what? Oh, but is it going to like it with the weekly data? Let's put, Core, what do you think? Let's put 5 minutes on the clock and try this. I want this one right here. I like the fun music. We're losing our 5 minutes. Okay, let's try this. 2 songs going. We got 5 minutes to try this. I vote yes. Me too. I love challenges because that would communicate a lot better. Like, this is the craziness right here. We want the line, and then we could maybe change the alpha of it. Does this have an alpha level? Because I'm going to lower the alpha on that. Alpha controls how... Doesn't look to have an alpha. Alpha controls the how visible the points are. Yeah, it'd be nice, right? I don't think... Let me look at the GG season and see if it has any sort of polar labels. No. I don't see anything that would indicate it has the capability on its own of doing it. So we need to like merge a plot. First thing we need to do is go to our US gasoline. We need to aggregate it. So we have to do like the weekly average, which frankly we could just display that. Like that would communicate the message in and of itself. So we want to go here to, okay, there's week. I might need to parse text. Because the problem is it's got the year. Get ready for some fun right here. String split. Take the data right there. There it is. It's a string. It's in quotes. That's good. So string split. This is something I should know immediately. Splits the elements of a character vector into substrings according to the matches and string split with them. Let me look at the... It takes a vector. Create 2 columns from character in R. Let's put column into columns. Okay, wait, I think I found something very similar. Separate vector. No. String split fixed. It's like a first and last name thing. Okay. Extract. It's a tidy function. Okay, wait. Here we go. Try this right here. I do not use this format at all. Did it. So there it is. There's the code. Thank you, Stack Overflow. I know dots and stars, and I need to know this format better. Like I like finding code that works, but I always say we should be able to read our code as a sentence. Extract from this data set the variable week, split it into year and week, like apart, so it makes the new columns right there. I do not understand the last argument that is using like special characters and telling it how to split. Pretty sure this is saying on everything before when there's a space. So we're basically there. So we've created this. We'll call this US Gas 2. US 2. It should still be a Tisbel. But US 2, I want to take week, which is a character vector, turn it into a factor, and overwrite the factor. Now we want to aggregate all this to get the aggregate on week. And was it barrel? And all of this. We're almost there. We're almost there. I know the bell rung, but... What? Oh, fun. Ha ha ha. Literally what I forgot last time. You gotta have fun. There we go. Okay, so there's that. And now... we are done. There it is, Cora. That's got it. There's the mean of every week. And this is what we were seeing in our crazy graphics in the viewer over here. Like, not the viewer, but the plots we were making, the crazy graphics. Not that one, but this graphic, I would like to overlay those graphics if I could. I mean, it doesn't look as fancy, but we can start to, we have the information. So this graphic right here, not that one. This graphic right here, this one, these dots right here, or these blue lines, all those blue lines are the information contained right here in those. Those are the blue lines. So if we really wanted, we'd go here, make it a little more evident, say col equals, where am I inside of this? Really? Color? No, I'm not getting any color. That's why I don't use that much. There's my values. Cool. Oh, it does the week down below. Well, let's try something right here. Let's go to auto plot or values. It doesn't like it because values right now is a table. And let me go to Geom. Is there anything with Geom? But yeah, there's the values. And can we do a time plot? TS plot on this? That's funny. Well, that's interesting. From the try it. Yeah, so there's a lot of fun stuff to be had right here. Really, we ended off this. We can just pipe it into a plot instead. But lots of interesting stuff. I don't know the color. I don't use color so often on the plots. Is it not? The plot should have color options. I just don't use plot nearly enough. You can't color the plot. No wonder I don't use this. Col. I said color, didn't I? I won't change colors. Well, we had a lot of fun with this. We got a plot. We got what we wanted. We could take this data and ggplot it, make it look a lot nicer, but that's the information we were looking for about the variation in the oil prices, and this is the seasonality pattern. Just trying to find better ways to communicate it. I know! What's going on with this? Like, I think it's something weird with it. I know I've done colors on this before. I've made colors. I know PCH, CEX, point style, point, all that stuff. Sometimes it just says no. Let's put the values over here and see if it likes that better. Maybe it doesn't like pipe. Is it? I think it's because there we go. the index is fine right here. And let's do one last thing. We're gonna end with this. Data frame, store into data frame. That's what we're end with. Here's how I would communicate this. Brain's breaking. Here's what I would do, Cora. We're about to incorporate 320. What? 53 weeks in a year? I have no idea why there's 53 weeks in a year. That is a mystery to me. Yeah, I guess there is. I mean, if you round up. Should have thought, I was like, wait a minute, let me think of the math. 364, yeah, one extra day. Then leap year, 366. So now, M save into LM. This is where we do the fun. Barrels explained by the week of the year. There goes that. Oh, haha. Data equals. Data frame. And all this work to look at the non-linearity of it. And I think, and we could go in and fit the polynomial to this, but there definitely seems to be not a linear trend to this. The sixth order to this, and we could make it do the sixth order, but there seems to be some sort of non-linear trend to this, and using all of our techniques here to talk about this, but there's definitely like an ebb and flow. And what's really interesting to me is this sudden drop at the start of the year. You can't really connect this in right here. It doesn't like cycle back or cycle, seasonality doesn't basically start back over. There's a sudden drop at the start of the year, which is interesting. It's like you start the year and everything. I guess you're just Christmas, you get the work done, and then you start back the year a little bit lower. So these are all the means right here, and we're just trying to make some better graphics. Well, that's got it. We're going to head off right here, just kind of having fun with data. That's what we do. Just like interpreting it. We got some pretty colors. That's where I was going towards. And yeah, we'll head off. I will see everyone later. 320 starting up here soon. Bye for now. Bye. Keep making those cool graphics.